Students trying to determine if a certain beetle will help control the population of a harmful plant species. Which steps would be the best suited for the investigation. Well, we're just looking at the scientific method. Which one is the scientific method? And we always start with a question. You ask a question. Well, first thing is actually you make an observation first, really. Then you ask a question about that. Why does that happen? And so we have stating a hypothesis way too early. And conclusion, that's the last step. We're getting rid of 2 and 3, but these have developed a question. And then we have conduct a experiment, state a hypothesis, make conclusions, and analyze your data. Well, everybody knows conclusions will be the last one. This one, you develop the question. You do your research first, really. There should be research in here as well, because a hypothesis is an educated guess. So you really need research in here before you can create an educated guess, but we'll let it slide here. An if-then statement. You make your predictions, and then you conduct an experiment. Then you look at the data and say, from the experiment, and say, did I get what I thought I should get? It says if I'm going to determine if a certain beetle will help control the population of harmful plants, say, if I release more of these beetles, then I'll have less harmful plants. Well, you do that experiment and see, hey, do I have less harmful plants around or not? And so if you do, you would support your hypothesis. It doesn't prove anything because something else might have happened to the plant, but it's looking good so far. So we would gain support. If the harmful plants didn't go away, then you would reject your hypothesis. And then after that, you still don't have a theory or a law. You publish this thing, and then other people come along. They perform the same experiment because science is repeatable. And if they would also either support or reject, and if it got enough support, that's when it would then, garner with the overwhelming evidence. That's when it becomes either a theory or a law. Theories and laws hold equal weight in evidence. It's just the way that they work. A law describes what happens, like Newton's laws of gravity describe how an object, if you drop it, it will accelerate. Here on Earth, it will accelerate at 9.8 meters per second squared towards the Earth. But even Newton himself said, I can describe how an object falls, but I don't know why it falls towards the Earth. And it wasn't until later on when Albert Einstein's theory of general relativity came out that we understood why objects that have mass also have gravity. So in that case, everyone says, oh, it's just a theory. In that particular case, the theory goes above and beyond what Newton's laws do. And so, but they're both very, very, very well established. Don't let anyone ever say, oh, that's just a theory.